Alright, hello once again, Jeff Scott of Rankin Technical College. And I've been, as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals class, I've been creating a series of video presentations based on the book for that class, Muroc C# 2019. The actual textbook has 26 chapters, and I'm in the middle of Chapter 6, How to Code Methods and Event Handlers. All right. So what I did previously was not too much in here, all right, but I've come in here and I have written a very, very simplistic little program that's simulating, emulating, whatever, aiding a calculator. All right. So notice I've got this, okay, and it's not bad. And actually, with what I'm going to do right now, you might think I'm making the program worse. All right. But what I want to do is I want to write a routine that'll do the addition, another routine that'll do the subtraction, another routine that'll do the multiplication, another routine that'll do the division, another routine that'll do the modulo. This routine can stay as it is. Maybe it's not that great, but I'm going to do it like that anyway. All right. To do these routines, I'm literally going to write a different routine, one called add, one called subtract, one called multiply, one called divide, and one called modulo. But for those routines to be able to do their thing, I'll need to pass in or provide the values of num1 and num2 for each one of these. All right. If you say I don't get it, then just watch if you would. So I'm going to write here private double add 2. I'll just call it add, and we'll say double number 1, double number 2, return n1 plus n2. All right. The good news is I'm going to be able to do a lot of copying and just make minimal changes. So this will be called subtract, and this will become a minus. Then this will be called multiply, and it'll have to be a times sign. And then you can probably see where this is all going. Divide, and that'll be a division sign. We'll put a little more code in there in just a minute. And finally, whoops, this last one will be called modulo. And we'll use the modulo sign. All right, now we've got these routines, but they're not being called right now. So we're going to say answer equals add num1, num2. First time we're making calls, method calls. Subtract num1, num2. Multiply num1, num2, divide num1, num2, modulo num1, num2. All right. Now, if we run the program again, so I'm going to save and run it again. You saw the numbers I put in there to keep it simple. Oops, we want to add 34 and 3. Good, it works. Subtract. Works. Multiply. Works. Divide. Works. modulo works, and this is probably not going to be big enough, but let's just put in something goofy in here like G. See, that's supposed to say illegal operation, but I didn't make it big enough. So we'll fix that. All right. Let's try it one more time with the illegal operation in here. So that's illegal. There we go. All right. All working. So what did this buy? Why did I do this? Was this a waste of time? Well, what I'm trying to show you in here, get back to our program right there, is rather than doing everything inside of a click event, which is what we've been doing, now that click event, all right, now that click event is calling other routines. Now I can keep it in there like this. There's absolutely nothing wrong with this. In fact, I'm going to grab every bit of this, every single bit. Let's see. Okay. And I'm going to comment it out. If you say why, give me a second. Actually, I should have copied it first, but that's okay. All right, so now I'm going to grab this code that's right here, uncomment it. Where is it? There it is. Okay. Why? Because I'm going to change this to a switch statement so you can see them both. So switch on up. Case plus. Answer equals add break. Whoops, not base. Case minus. Answer equals subtract. And break. Case multiply. The answer equals call to multiply. And break. Case divide symbol. Answer equals divide and break. And finally, case modulo. And break. Oops, I don't know what the heck happened there. Finally, default. Technically, when we have a default, since it's at the bottom, you don't need a break, but it never hurts. All right, so now I've got my program again, and I've written it in yet another way. I'm going to go back over all of it as soon as I run it to make sure it still works. 34 plus 3, fine, minus, fine, times, divide, and modulo. And hopefully you can see that it still works. I put in there an F, I get my illegal operation. The clear works, the exit works. So why did I take all the time to show you that? Not to waste my time, not to waste your time. All right, but to show you how similar it is to use an if or a switch. But the point is, in either case, we're making a call here to a function or method. And that function or method here is called add. In order for add to do its job, it needs to know what the two numbers are. All right? And then when it gets done, it'll have to return a value that's of type double because that's going to be stuffed into A and S. So when we look, there's add. Returns a double. That's its name. Notice that they were called num1, num2, and now I call them n1 and n2. I can call them Bill and Ralph. It'll be fine. But then I'd have to say return Bill plus Ralph. All right? These right here, when they're written inside of a routine, these are called formal parameters. Up here, where we actually describe them, they're called actual parameters. But what I want to show you is whether I used an if or a switch. In both cases, I was calling a routine. There's the name of the routine. There's the parameters or the information that the routine needs to do its job. This is what's going to hold the result of the call to that routine. Now, again, I'm not saying, hey, that's it. Does that totally make sense? Because it might make little sense. All right? But to me, what I just showed you is worth a lot more than what the author did, for lack of better words. All right? You don't have to return a value, but you can. So the author talks about in here, there's a method that doesn't return anything. If it doesn't return anything, its type must be the word void. It's void of a return. There is none. Here's one that returns a decimal. We could have made ours a decimal instead of a double. It didn't matter. Here's one, another one that returns a decimal, and it has 1, 2, 3 things passed into it. Our routine had 2 things passed into it, the first number and the second number. This one had nothing passed into it. This one had 1 value passed into it. All right? So we could say the word this in front of there, which means whatever we're currently working with. So in other words, I could have taken any one of these routines, and instead of add here, I could have said this dot add, and it would work too. All right? If you say I don't understand what this means, it'll be explained in more depth and breadth of coverage later on in the text. All right. Once you write a method, the IntelliSense picks it up, so it'll know what you're trying to call. Or you can call built-in methods. All right? Now, let's suppose for a second, I'm going to go over this right now, this optional parameters. But what I'm saying to you is let's pretend, let's suppose for just a second that we are writing a routine, or in fact, we're close to 15 minutes. Let me stop here, and I will continue on in the next lesson in just a minute.